In problem 1, we're trying to figure out which of the following properties about the correlation coefficient are true. The first statement says that correlation is always between -1 and 1. This is a true statement. The second statement says that correlation coefficient close to 0 means that there is no relationship between the two variables. In general, we look at correlation coefficient as a measure of the strength of the relationship, but you need to make sure that the variables that you're looking at are in fact in a linear relationship. If I had data that fell in this sort of relationship, which is nonlinear, but they seem to fall very closely to some sort of parabola, then that means that my correlation is 0, but there is a relationship between the two. So the correlation coefficient only tells us about linear relationships, not about all relationships. Third, if the correlation coefficient is -1, then the slope of the regression line will also be -1. This is not going to be a true statement because I could have values that go very quickly downward, where my slope looks like it's something like maybe -2 when I look at rise over run. And with that, my correlation is close to -1, but my slope is not. So slope and correlation have the same sign, but they don't necessarily have to have the same value. In fact, most of the time, they will not. Correlation must always be greater than 0. That's not true. We know that correlation can be anything between -1 and 1. If the correlation is negative, then the slope of the regression line will also be negative. That is a true statement. So if our slope's negative, correlation will be negative and vice versa. And lastly, the correlation coefficient will change if we change the units of measure. Notice that for both of the pictures that I drew, I did not need any sort of units, and I could still figure out what correlation was going to be. So correlation is unaffected by units, and if I change the units, it will not change the correlation.